Waking up one morning to realize that everything you thought you knew about air superiority is wrong, that the skies, long dominated by the West, are now contested in ways no analyst predicted. Advanced jets, faster, smarter, and stealthier than anything you've seen, are rewriting the rules of aerial warfare and shifting the balance of global power overnight. The breakthrough in stealth capabilities represents one of the most striking developments in aviation that completely blindsided Western defense analysts. For decades, stealth was considered a domain firmly dominated by Western powers, particularly the United States, with aircraft such as the F-117 Nighthawk, the B-2 Spirit, and more recently, the F-22 Raptor and F-35 Lightning II being showcased as unmatched in radar-evading technology. This dominance created a false sense of security, a belief that no other nation could close the gap within a short time frame. Yet, what emerged was a new generation of stealth jets from unexpected regions, developed with techniques and materials that had not been properly tracked or even fully anticipated. The airframes demonstrated highly irregular angular shaping designed to scatter radar waves more efficiently than existing Western models, and their use of advanced composites and nanomaterial coatings provided an added layer of invisibility that radar operators found frustratingly difficult to detect. Even more surprising was the incorporation of adaptive camouflage systems that blurred not only the radar signature but the visual profile of the jet itself, adjusting its heat emissions and even exterior coloring in real time to mimic the sky, clouds, or ground below. This innovation moved beyond traditional stealth, which largely depended on minimizing radar cross-section, and entered a realm closer to science fiction, where a fighter jet could effectively disappear not just from screens, but from the naked eye. Western defense experts were caught off guard because they underestimated how much research had been poured into these areas outside their usual spheres of observation. They had assumed that stealth breakthroughs would require the same level of resource investment and long developmental cycles seen in their own programs. But what unfolded was a model of efficiency, where new materials, science, and rapid prototyping created a leapfrog effect. While Western analysts debated incremental improvements to existing stealth fleets, these newcomers introduced jets that operated on principles of invisibility that bent the rules of traditional detection. Pilots reported in exercises that these aircraft could approach within striking distance before even being picked up, rendering traditional early warning systems obsolete. This forced a re-evaluation not only of stealth as a Western monopoly, but of the very assumptions guiding future warfare. The most unsettling realization for Western strategists was that their adversaries were no longer playing catch-up, but were, in some critical aspects, running ahead. The integration of supersonic and hypersonic capabilities into next-generation jets represents a seismic shift in aerial warfare that Western defense analysts failed to anticipate. Traditional jet design often forces a trade-off between speed, stealth, and maneuverability, with engineers spending decades optimizing each attribute separately. What caught analysts off guard was the emergence of aircraft that successfully combined extreme velocity with advanced stealth features, allowing them to operate at speeds previously reserved for experimental or highly specialized aircraft. These jets are not only capable of sustained supersonic flight, but some even reach hypersonic thresholds, exceeding Mach 5 while maintaining structural integrity and operational precision. The engineering behind such performance relies on breakthrough materials capable of withstanding extreme heat generated at these velocities, along with adaptive airframe designs that reduce drag and maintain control without compromising stealth characteristics. Engines are also a critical factor, incorporating variable cycle and scramjet technologies that optimize thrust across both subsonic and hypersonic regimes, enabling rapid acceleration, extended range, and agility that rivals conventional fighters. Beyond the technical marvel, the strategic implications are profound. Jets equipped with hypersonic capabilities can strike targets across vast distances in mere minutes, leaving traditional air defense systems struggling to respond and rendering early warning radars and missile interceptors largely ineffective. This advantage is amplified when paired with stealth technology, as detection windows shrink to the point where response times are nearly non-existent. Analysts had assumed that these breakthroughs would emerge gradually, with incremental testing over decades, but what transpired was a rapid integration of speed and stealth in operational platforms that could challenge established air superiority doctrines. Furthermore, these jets are being designed to carry advanced payloads, including precision-guided munitions and hypersonic missiles, effectively allowing a single aircraft to penetrate enemy airspace, evade detection, and neutralize high-value targets before conventional forces can react. The convergence of stealth supersonic and hypersonic technologies represents not just an incremental improvement, but a transformational leap in aerial combat, redefining what constitutes superiority in the skies. Western defense analysts were blindsided because their assumptions relied on linear progression, expecting incremental improvements rather than a simultaneous breakthrough in multiple domains. The rapid emergence of these aircraft forced a reassessment of combat strategy, radar development, and response protocols, revealing a gap in foresight and technological anticipation that left established powers scrambling to adapt to an entirely new paradigm in air warfare. The integration of artificial intelligence into jet combat systems has redefined the very nature of modern aerial warfare, catching Western defense analysts completely off guard. Traditionally, air combat relied heavily on human pilots, making rapid calculations under extreme pressure, processing radar data, monitoring multiple systems, and responding to unpredictable threats. This human-centric model, while sophisticated, inherently comes with limitations in reaction time, multitasking, and predictive analysis. What emerged in recent jet developments is a fusion of AI-driven avionics and autonomous decision-making capabilities that surpass traditional human performance. These systems can analyze vast streams of sensor data in real time, anticipate enemy maneuvers, and execute complex flight patterns with precision far beyond human reflexes. For instance, AI-assisted targeting algorithms allow these jets to identify, track, and engage multiple targets simultaneously, calculating trajectories, velocities, and environmental variables with millisecond accuracy. This level of automation reduces the cognitive burden on the pilot and enables faster, more effective combat responses. The AI systems embedded in these jets are adaptive, meaning they learn from each engagement, continuously refining their algorithms to improve performance in unpredictable scenarios. This is a stark contrast to older aircraft, which rely on static programming or pilot intuition for decision-making. Predictive modeling allows these jets to anticipate enemy strategies, respond preemptively, and exploit weaknesses in air defense networks that were previously thought to be impenetrable. Western defense planners underestimated the speed at which AI could be integrated into operational combat aircraft. The assumption was that autonomous or semi-autonomous flight capabilities would remain experimental for years, perhaps even decades, and would require extensive testing before real-world deployment. However, these new systems demonstrated not only operational readiness, but also a level of sophistication that could challenge the best-trained human pilots. Another critical dimension is AI-enabled swarm coordination. Multiple jets equipped with interconnected AI systems can communicate in real time, orchestrating complex maneuvers, flanking strategies, and synchronized attacks without direct human oversight. This allows for the creation of dynamic aerial formations that maximize offensive potential while minimizing exposure, making traditional dogfighting tactics obsolete. The combination of autonomous intelligence, predictive targeting, and swarm coordination means that these jets operate not merely as aircraft, but as intelligent combat units capable of making strategic decisions in the midst of battle. Western analysts had largely focused on incremental improvements to avionics and pilot assistance systems, failing to anticipate a paradigm shift where the aircraft itself could act as a decision-making entity. The integration of AI in jet combat systems thus represents a revolutionary leap, fundamentally changing both the operational landscape and the assumptions about air superiority that had dominated defense thinking for decades. The advancements in electronic warfare capabilities embedded in modern jet technology have created a profound and largely unexpected shift in aerial combat, leaving Western defense analysts struggling to catch up. Previously, electronic warfare was considered a supporting element of military strategy, with separate platforms dedicated to jamming communications, disrupting radar signals, or conducting cyber operations from a distance. The new generation of jets, however, integrates these capabilities directly into the aircraft itself, transforming it into a mobile electronic warfare hub capable of dominating the electromagnetic spectrum in real time. These jets can actively interfere with enemy radar, rendering traditional detection systems nearly useless while simultaneously cloaking their own movements. By disrupting communication networks, they can isolate units on the ground or in the air, preventing coordinated defensive responses and creating confusion that can be exploited during high-stakes engagements. This level of integration was not something Western analysts had predicted, as it required combining high-speed flight, stealth, and sophisticated electronic systems without compromising the aircraft's performance or maneuverability. One of the most surprising features is the jets' ability to conduct signal hijacking and targeted electronic attacks mid-air. Instead of merely jamming frequencies, they can infiltrate enemy radar and communication networks, sending false signals, creating phantom targets, or feeding manipulated information into command systems. This not only degrades situational awareness but actively misleads adversaries, causing them to make tactical errors that can be devastating in a conflict scenario. Such capabilities extend to countering missile guidance systems, disabling or confusing incoming threats, and providing a level of self-protection that previously required dedicated escort or support aircraft. The integration of these functions into a single, agile platform represents a revolutionary shift in the design philosophy of combat aircraft, blending kinetic and non-kinetic warfare into one unified system. The adaptability of these electronic warfare systems is exceptional. Using AI-driven algorithms, the jets can detect changes in enemy tactics, adjust jamming patterns dynamically, and optimize their operations for maximum disruption. This means that even highly sophisticated air defense networks, which had been considered resilient and robust, can be neutralized or significantly degraded in real time. The unexpected speed at which these technologies were developed and deployed left Western defense planners scrambling as conventional methods of countering electronic warfare were rendered largely ineffective. Analysts had assumed incremental evolution of these systems over years, if not decades, but the reality was a rapid leap forward that reshaped the entire aerial battlefield. In essence, the fusion of electronic warfare capabilities directly into the jet itself has created a platform that can control, deceive, and dominate in ways that were previously unimaginable, fundamentally altering the calculus of air superiority and redefining the rules of modern combat. The unexpected game-changing factor in the development of modern jet technology lies in the combination of streamlined production, affordability, and rapid deployment. which completely challenged Western assumptions about how advanced military aircraft are built and fielded. Traditionally, the creation of cutting-edge jets has been an extremely costly, time-consuming process, dominated by bureaucratic red tape, multi-billion-dollar budgets, and years of testing and incremental improvements. Western defense analysts often assumed that any nation attempting to match or surpass these technologies would inevitably face similar constraints, limiting the pace of innovation. What took them by surprise was the emergence of jets that achieved comparable or even superior performance without the massive financial and temporal burdens that Western projects typically incur. These new aircraft were the product of highly efficient production methods, leveraging modular designs, advanced manufacturing techniques like 3D printing for critical components, and optimized supply chains that allowed for rapid iteration and field deployment. This approach drastically reduced costs, making it possible to produce multiple units at a fraction of the expected price, while simultaneously implementing sophisticated technologies such as stealth materials, AI avionics, and hypersonic propulsion. Beyond affordability, the speed of development and deployment has been revolutionary. Western analysts had long believed that cutting-edge technology would trickle out slowly, with years of testing required before operational readiness. In contrast, these jets moved from conceptual design to functional deployment at an unprecedented pace, demonstrating a combination of strategic foresight and practical efficiency that defied conventional expectations. Rapid prototyping allowed engineers to test, modify, and integrate new systems quickly, while streamlined production cycles ensured that multiple aircraft could be brought into service simultaneously, creating an immediate operational impact. This agility in development and deployment not only caught analysts off guard, but also changed the strategic calculus for air power. Nations could now field advanced jets in numbers sufficient to alter regional power dynamics almost overnight, without waiting decades for traditional defense programs to mature. The cost-effective nature of these jets challenges long-held assumptions about technological superiority. Western powers often equated high price with high performance, believing that cutting-edge aircraft had to be prohibitively expensive and limited in quantity. These new designs shattered that notion, proving that innovation, efficiency, and strategic resource allocation could produce aircraft that rivaled or surpassed expensive counterparts. This combination of affordability, rapid deployment, and technological sophistication provided a decisive advantage, allowing nations to field modern air forces capable of challenging traditional superpowers. Western analysts, accustomed to viewing advanced jet programs as slow, costly, and bureaucratically constrained, were blindsided by the speed, efficiency, and strategic impact of these developments. The unexpected emergence of a production and deployment model that prioritized both performance and practicality has created a paradigm shift, forcing military planners to reconsider long-held assumptions about how air superiority is achieved and maintained. The strategic geopolitical impact of the new generation of jet technology has been profound, reshaping global power dynamics in ways that Western defense analysts did not foresee. Historically, air superiority was considered a cornerstone of military dominance, with Western powers maintaining a near monopoly on advanced fighter jets, stealth bombers, and precision strike aircraft. This technological edge allowed them to project power globally, influence conflicts remotely, and maintain a sense of strategic security. The sudden emergence of jets with unprecedented stealth, hypersonic speed, AI integration, and electronic warfare capabilities has disrupted this long-standing balance. Nations that were previously considered secondary players in terms of air power can now wield advanced aircraft that rival or even surpass the capabilities of traditional Western fleets, creating a seismic shift in geopolitical leverage. This rapid transformation challenges the assumptions that Western analysts held for decades, underestimating both the speed of innovation and the ability of non-Western nations to integrate cutting-edge technologies efficiently. The presence of these advanced jets in strategic regions has immediate implications for deterrence and power projection. Airspace that was once considered secure or uncontested can now be penetrated with minimal warning, reducing the effectiveness of early warning systems and forcing a re-evaluation of defense postures. Nations equipped with these aircraft can exert influence over contested territories, maritime choke points, and border regions in ways that were previously unimaginable. The psychological impact alone is significant. Military planners and political leaders must now account for the possibility that adversaries possess platforms capable of executing precision strikes at extreme speeds while evading detection. This creates uncertainty and strategic vulnerability, compelling established powers to reconsider alliances, defense investments, and operational doctrines. The geopolitical ramifications extend beyond immediate military applications. The rapid adoption of advanced jet technology signals a shift in industrial and scientific capacity, demonstrating that nations outside the West are not merely imitating but innovating independently. This erodes the perception of technological superiority that Western nations once held and alters the dynamics of international negotiations, arms deals, and defense cooperation. Countries with these advanced jets gain leverage in both regional and global affairs, influencing diplomatic outcomes and altering the balance of power. Analysts failed to anticipate how quickly these technological breakthroughs could translate into geopolitical advantage, assuming that innovation would be gradual and constrained by financial, technical, or logistical limitations. Instead, what emerged was a paradigm where strategic influence could be rapidly amplified through technological sophistication, operational readiness, and cost-effective production. The geopolitical impact of these jets is not limited to battlefield superiority. It fundamentally reshapes the way nations perceive power, security, and their position on the global stage, forcing a re-evaluation of strategies, assumptions, and long-held doctrines that had dominated Western defense thinking for decades. The emergence of this new generation of jet technology has exposed a fundamental truth. Technological dominance is never permanent, and assumptions about superiority can be shattered in the blink of an eye. From revolutionary stealth capabilities and hypersonic speed to AI-driven combat systems, electronic warfare mastery, and efficient production models, these jets represent a leap that Western defense analysts did not foresee. More than just machines, they are instruments of strategic influence, altering regional and global power dynamics in real time. The lesson is clear. Innovation can come from unexpected places, and the future of air combat is being defined not by tradition or expectation, but by bold, unforeseen leaps in technology and strategy. Those who fail to recognize and adapt to this new reality risk being left behind, watching as the skies they once dominated are transformed before their very eye.